Welcome to this video. So in this video, we are going to solve a double integration question, okay, that requires us to change variables. Okay, so some of these questions that we are going to be given, when you sketch or draw their region, okay, it's going to be a very complicated region such that we can't classify it as a type 1, okay, or a type 2. Okay, so to simply integrate such integrals, we are going to transform the variables, okay, from the XY plane to some other planes, let's say the UV plane. Okay, so let's read this question and then actually solve it. So they're saying evaluate the double integral, okay, x squared plus y squared, okay, where over the region R, where R is the region bounded by the curves, okay? X squared minus y squared is equals to 1. X squared minus y squared is equals to 9. Xy is equals to 2. And xy is equal to what? To 4. Okay, so actually we have to draw this region using this information that we've been given, okay? So here we can actually identify, okay, we can actually identify what this curve is. Okay, so this here is nothing but just a what? A hyperbola. Okay, and then this one is also a what? A hyperbola. Okay, so this one will have the vertices at 1. This one will have the vertices at 3. So how do we find the vertices? We just take the square root of the number that is on the what? On the right-hand side. Okay, so we can start with this. So this x squared minus y squared is equals to 1. This is a hyperbola, okay? And it will have vertices at 1 and minus what? 1. So we can say the vertices will be equals to the square root. Okay, so plus or minus the square root of 1, which is just plus or minus 1. Okay, so it means they will be tending like that and like that at 1 and negative 1. Okay, so if I was to sketch my XY plane here, okay, if that is my XY plane, let's say this is our Y, and then this is my X. If this is 0, okay, I'll have a 1 somewhere there and a minus 1 somewhere. So it means this hyperbola, I mean, not parabola, okay, it will be a parabola that comes like this. It opens, okay, to the left of the x-axis and actually opens to the right of the x-axis like that. Okay, so this is 1, that is minus 1. All right, what about this parabola here? So this one, x squared minus y squared is equals to 9. So it means that the vertices there are just going to be plus or minus the root of 9. So this will just be plus or minus 3. So it means somewhere here I'm going to have a minus 3, and somewhere there I'm going to have a 3. So this will be a parabola that is opening to the left, passing through the minus 3, and then the other part will be passing through the 3, opening this side like that. Okay, so that will be our two parabolas. And then we were told that this region, okay, we're sketching the region, is also bounded by xy is equals to 2, as well as xy is equals to 4. So what we do here is just make y the subject of a formula. So this will be 2 over x. And then this one will be y is equals to 4 over x. Okay, so we can actually try to find some points. Okay, so if, for example, I have my 4 somewhere there, okay, as my x value. Okay, so can we evaluate these two curves at 4 is equals to, okay, so let's draw a table of values. So the table of values will look something like this. Okay, so I'll put x here, and then here I'll put y is equals to 2 over x. And then down there, I'm going to put y is equals to 4 over x. Okay, so if my x is 1, and then I'll also say if my x is 2, and then if my x is, okay, my x is 4. So if my x is 1 here, what will happen to this? This will be 2. If this is 2, okay, this will be 1. If this is 4, it will be half. Okay, so this will help me plot this guy here. And it will also help me to identify whether this graph is above this one or this one is above this one. So if x is 1, then what will happen to 4 over x to just become 4? Okay. If x is 2, what will happen to 4 over x? It will become 2. If 4 is 4, what will happen? It will become 1. Okay. So at this one here, if we were to plot, if we were to do a rough sketch, okay, if I'm plotting this curve here, which is this one here, okay. So at 1, I have that it is 2. So it's somewhere there. And then 2 can be somewhere in between 1 and 3. So if it's 2, then I have that this curve is at 1, okay? Remember, it's not a straight line. These points are just helping me, okay? Because this is a rational function with the y-axis and the z-axis and the x-axis being the asymptotes. Okay, and then if x is 4, okay, it's telling me that this guy will be half, so somewhere there. So remember, what I'm saying is that since we are dealing with rational function, these ones here, so it means this one, okay, the x is equals to 0 is the asymptote. Even this one, the y is equals to 0 is also the what? The asymptote. Okay, so this one, this curve here, okay, will be coming from this asymptote and then to go like this and go like that. Okay, it's not a straight line, so don't draw a straight line. So it will be like that. And then now I want to sketch this one here. Okay, so this one, it will be 1, comma 4. So at 1, I'm going up to 4. So 4 can be somewhere there. Okay, at 2, I'm going up to what? To 2. Okay, so 2, at 2, I'm going up to 2, so it can be somewhere there. And then at 4, I'm going up to what? 1, which can be somewhere there. So it means this one now goes like that. Okay, so our region which we are interested in is which region now? So the region that we're interested in is this one here. Why? Because it's the one which is bounded by this hyperbola, okay? This first one. And then I can also see this hyperbola here, this second one. I can see this curve, which is this one below, and I can see this curve, which is this one above. Okay, so we can actually label them. So this one is x, y is equals to 4. This one here, okay, is x, y is equals to 2. And then this one in black is x squared minus y squared is equals to 1. And then the one in red, okay, this one here, it is x squared minus y squared is equals to 9. Okay, so our region of integration is this one here. So this is the region we're interested in. Okay, so it can be very difficult for us to classify this region as either a type 1 or a type 2 so that we can integrate easily. Okay, so what we are going to do is we are going to change this region. Okay, we're going to transform it from the XY plane, we're going to transform it into the what? The UV plane. And then in the UV plane, you see that it will be a very simple region that we can easily integrate over. Okay, so now let's work with the transformations that we've been given there. Okay, so they have said use the transformation u is equals to x squared minus y squared and v is equals to 2xy. Okay, so that's what we are going to do. So the first thing is we are changing the variable, okay, is that we have to find the Jacobian, okay? We have to find the Jacobian, okay? So if I can give the formula, okay? So remember, we're trying to find some region R prime, okay, in the what? In the UV plane. So our integral, okay, this one, okay, once we change the variables, okay, it will be something like this one. It will be the integral, but now this r will change to r prime, okay, and then this function, okay, the y squared plus x squared plus y squared, okay, it will be represented in terms of what? U and v. Okay, because we are in the UV plane. So that simply means that the x will be represented in the form of u and v. And then even the y will also be represented in terms of u and v. Okay, so this will be our function here, represented in terms of u and v. And then we have to multiply this by the Jacobian of changing from the xy plane to the uv plane. So that Jacobian, okay, will just be partial of partial of xy divided by partial of uv. So this will be our Jacobian, and then we'll put du dv. Okay, so what we are trying to find now using these transformations is one, this Jacobian here. Okay, so the Jacobian should be in the form that from the plane where you're coming from. Remember, we're coming from the xy plane going to the what? To the uv plane. So it means in your Jacobian, the x and y should be on top. Okay, and then where you're going, the uv plane, the u and v should be down there. Okay, so from these, they're going to help us find the Jacobian one. Okay, and then using these same transformations, we are going to express this x squared plus y squared in terms of what? In terms of u and v. And then once we do that, you see that our sketch for the region will be a simpler one than this one, which is complicated. And then we can evaluate our integral. Okay, so let's do that. Okay, let's find the Jacobian. Okay, so since we have u is equals to x squared minus y squared, and then we have v is equals to 2xy, okay, we can easily find the Jacobian. Okay, so since here we have u and v being expressed in terms of x and y, we can find the Jacobian uv over xy. But remember, in our integral, we need the Jacobian from the xy, the uv plane. So it means the Jacobian that we're going to find here, we're going to do a reciprocal. We're going to say 1 over to find this one, we're going to say 1 over this Jacobian. Okay, so this Jacobian is equals to, okay, u, okay, partial of u with respect to x. Okay, so what is the partial of u with respect to x? Okay, so I just write ux and then I do uy, and then now it will be v. Okay, so partial of v with respect to x, and then partial of v with respect to y. So this will be equals to, okay, so partial of u with respect to x, I get 2x. Partial of u with respect to y, I get minus 2y. Partial of v with respect to x, I get 2y, okay? And then partial of v with respect to y, I get 2x, right? Okay, so that would be my Jacobian there. Okay, that will be my Jacobian there. So let's multiply and then see what we are going to come up with. Okay, so this is going to be equals to this multiplied by this. I get 4x squared minus 4, okay, y squared. So this is what I get. So this simply means 4x squared plus 4y squared. Okay, so our Jacobian, when we're coming from the uv to the xv, is this one. But remember, I want the one where I'll be coming from, where I'll be coming from the xy to the uv. Okay, so to find this one here, I'll just take the reciprocal of this. So what I'm going to do is this. Okay, we're going to say Jacobian from xy plane to the uv plane is actually equals to 1 over the Jacobian of the uv plane to the xy plane. So I'm going to put 4x squared plus 4y squared. Okay, so this will be our Jacobian. So I can write this as 1 over 4x squared plus y squared. So this is the Jacobian. Okay, so I'll write it on top here. We are going to use it later. So Jacobian is 1 over 4x squared plus y squared. Okay, so we are done finding the Jacobian. Okay, what we need now is to find the function. Okay, so we want to express this guy in terms of u and v. Okay, want to express that guy in terms of u and v. Okay, so what we are going to do is that I have u is equals to x squared minus y squared. V is equals to 2xy. Okay, so this simply means that I can come up with an expression. Okay, that is going to help me solve this question. So that expression, I'm going to say, what if I get u plus v? Okay, and then I square them. What am I going to get? Okay, so remember here I have x squared plus y squared. So I'm trying to come up with something that is similar to this. No wonder I'm squaring these two guys. So when I square this, I get u squared plus 2uv plus v squared. So I can also write this as u squared plus v squared plus u 2uv. So that similarity that I was talking about, you can now see it. Here it's x squared plus y squared. I can see u squared plus v squared. So this means that, okay, I'm going in the right direction. Okay, so let's make this the subject of a formula. Okay, so when we make u squared plus v squared the subject, it means I have u plus v squared minus 2uv. That's what I have. Okay, so now let's replace the ones on the right hand side with their values in terms of x here. Okay, so what I'm going to say is that here where there's u, I put y squared minus x squared minus y squared. Where there's v, I put plus 2xy. Okay, and then squared minus 2. Where there's u, I put y squared minus x squared minus y squared. And then where there's v, I put 2xy. Okay, so that's what I have. Okay. All right. So let's continue expanding this. So remember, this is u squared plus v squared. So let's expand the right-hand side. Okay, let's expand the right-hand side. So the right-hand side, okay, when we expand it, okay, what are we going to get? So it's simply this x squared multiplied by itself, multiplied by this, multiplied by this. So what I get is, so I'm going to say u squared plus v squared is equals to x squared multiplied by itself, I get x to the power 4. Multiplied by this one, I get minus x squared y squared. When I multiply it by this, okay, I get plus 2x to the power 3 y. Okay, so I've done multiplying this part with everything. So now I get y squared minus y squared, I multiply with everything. So the first one, I get x squared y squared, and then I get plus y to the power 4, and then I get minus 2xy to the power 3. Okay, so I'm done with this bracket. I come to, oh, no, I'm not done. I have to multiply this one with everything as well. So this one multiplied by itself, I'm going to get plus 4x squared y squared. And then this one multiplied by x squared, I'm going to get plus 2x to the power 3 y. This one multiplied by this, I get minus 2xy to the power 3. Okay, so that is what I get there. Okay, that's what I get there. And then now let's expand this side. Okay, so let's first multiply this 2xy with, so I'll just write it here. So 2xy multiplied by y squared, I get 2x to the power 3y. Okay, and then 2xy multiplied by minus y, I get minus 2xy to the power 3. So this is what I have inside, and then I expand with this 2 outside. So I'm going to get minus 2. I'm actually going to get minus 4. I'm going to get minus 4. Okay, I'm going to get minus 4x to the power 3y. Okay, and then multiplied by this, I'm going to get plus 4x y to the power 3, like that. Okay, so now you notice that some of the terms there are going to cancel out. Okay, so let's put like terms together. So u squared plus v squared. Okay, this one to be x to the power 4. Okay, I can get this one. So this one I've gotten, this one I've gotten. From here, I'm going to target which ones? Okay, I'm going to target which ones? I'm going to target these ones here with the y squared minus y squared. Okay, minus y squared. I'm going to get x minus x squared y squared. So there's this one and this one. So I'll add them. I get minus 2 x squared y squared. And then I also get this one, which is just a plus 4x squared y squared. Okay, so I'm done with this one, done with this one, done with this one. And then now I get this 2x to the power 3. I can also see 2x to the power 3. So I add this and this. I get what? Plus 4x to the power 3y. And then I can also see 4x to the power 3y. So that will be minus 4x to the power 3y. Okay, so which ones am I remaining with? I'm remaining with these ones here. I'm remaining with this one, minus 2xy to the power 3 and minus 2xy to the power 3. So I get minus 4xy to the power 3. And then I can also see plus 4xy to the power 3. So what do we notice? We see that these ones here cancel out. Even these ones here cancel out, okay? And then these ones, we can subtract them because they are both y squared, x squared. So it means my u squared plus v squared is actually equals to x to the power 4, okay, plus y to the power 4, and then plus 2x squared y squared. Okay, so that's what we get there as our as our u squared plus v squared. But now notice that this one here, okay, this one here is it's just the square of y squared plus, I mean, it's a square of x squared plus y squared. Okay, so I'm going to write it as x squared plus y squared to the power 2. This will be equals to v squared plus what? Y squared. So this one, when I expand it, I will get this one. So you try it. So x squared multiplied by x squared, I get this. Y squared multiplied by y squared, I get this. And then x squared multiplied by y squared, I get 1 x squared y squared. Y squared multiplied by this, I get another x squared plus y squared. And then I add them, I get 2. Okay, so that's what's important there. So this one actually is going to help us. Okay, so here I'm going to say u squared plus v squared is equals to x squared plus y squared and then 2 outside. So now my interest to make this thing in terms of u and v. So I can easily make it here. So I'll just square root. Okay, so if I square root this side and then I square root that side, it means my x squared plus y squared is actually equals to what? The square root of u squared plus v squared. Okay, and that is a beautiful transformation that we are going to use, okay? Because I can see y, x squared, y squared is even in the Jacobian there, and then it's also even in the function, okay? So it means my function, this one, is just this one, okay? So my integral now will look something like this. It will be integral over the new region R prime, okay? We are yet to find this region. This x squared plus y squared has become u squared plus v squared. Okay, and then I'm multiplying by the Jacobian, remember, which is 1 over 4 x squared plus y squared, which is the same as this thing. So here I'm just going to write square root of u squared plus v squared, and then I'll put the a prime here, okay, for this region. So we see here that the root, this one and this one will cancel. Okay, so what are we going to remain with? We're going to remain with the integral over the region R prime, 1 over 4, and then the A prime. Okay, so the only thing now is to find the R. Okay, so the R prime, remember we had said that U is equals to this part, right? Okay, so since x squared minus y squared is equals to 1, and then this x squared minus y squared is also equals to 9, okay? But u is just equals to this part. So this simply means that u is equals to 1 and u is equals to what? 9. Okay? And then the xy, okay, I'll write it here. Xy was equals to 2. I mean, the xy was also equals to what? To 4. And then from our transformation, we're told v is equals to 2xy. Okay? So when I multiply this by 2, also multiply that side by 2. This by 2, also multiply that side by 2. So here I get what? 4. Here I get 8. And this will be v. Even this one will be v. So in the UV plane, okay, U is always on the horizontal one, and then the V there. In the UV plane, okay, it means I have these 4 straight lines here that would describe my region. Okay, and you see that it will be a very simple region. So let me write it here. Okay, so this is my V, and then I have my what? My U. Okay, so my U is from 1 to 9. So 1 can be somewhere there. Okay, so this is my 1. Hey, what's happening? Okay, so this is my 1, and then this is my 9. Okay, so that is for you. And then for V, I have these 2 straight lines. Okay, so this one down is for 4. This one up is for 8. So what is the region now? The region is this one. Okay, and you see this will just be an iterated integral. We can pick it as a type 1 going like this. Okay, at a type 2 going like this, but we have constants everywhere. Okay, so it doesn't even matter if it's a type 1 or type 2. We can use it anyhow that we want. Okay, so it means our u is from 1 all the way to what? To 9. Our v is from 4 all the way to what? To 8. So now we can replace this dA prime with the du dv, and then the r prime we can replace it with those limits. Okay, so before I even erase this, can you see that this region here in the UV plane, it's so easy to deal with than this one in the XY plane. Okay, so that's why here we were changing the variables so that it becomes easy like that. Okay, so now we can erase this part, and then we evaluate the integral. Okay, so the integral now becomes, okay, I can put this in any order. So I'll start with V. Okay, so V is from what? 4 to 8, and then the inside one is from 1 to 9. Okay, so our integral is just 1 over 4, and then this one, since we started with the V here, means this one inside is the U. So I'll start with du dv. Okay, so it will be 4, 8, and then this one to be U over 4, and then I put 9, 1. So that would be the integral of 4 to 8 over 9 over 4 minus 1 over 4 dv. So here I forgot to put a dv. So this simply means that we have what? We have the integral from 4 to 8 of 9 minus 1, which will just be 8. Okay, which will just be 8. Okay, 9 minus 1 is 8, and then divided by 4, it's 2. So dv. So we are integrating that. Okay, so we're going to say our integral will just be 4 to 8 of 2 dv. Okay, so if we integrate this, it will be 2v, and then I have 4, 8. So this one will just be 2 multiplied by 8 minus 2 multiplied by 4. So this will be 16 minus 8. So it means our final answer will just be what? 8. So the integral, this one, gives the answer as 8. All right, so thank you for watching. That's all for this video. If you'd like to access full written solutions to advanced calculus tutorial sheets, okay, please, you can inbox me. I give you access to the app, okay, and then on the app, you can access those solutions. All right, have a blessed night.